All right, let's look at this next example. This next example is actually a little bit more tricky because there's actually a very important rule that is exhibited by this next example. I have tangent of x times sine squared of x is equal to 2 times tangent of x. So some of you might be thinking, oh, tangent appears in both of them. Why don't we just divide him away? Unfortunately, you cannot do that here. By dividing tangent of x away, we would actually eliminate possible answers, possible solutions. So dividing is not allowed. Dividing is a no-no. Okay? A very good first step is actually getting this set equal to 0. So I'm going to bring this 2 tangent of x over by subtracting him onto the left-hand side. So tangent of x times sine squared of x minus 2 tangent of x is now equal to 0. Now remember I had said before you cannot divide. Well, the alternative to division is factoring. We can factor out a tangent of x from both of these terms. From my first term, I'm left with sine squared of x. From my second term, I'm left with minus 2. We're now equal to 0. Remember, that was a rule that you learned in Algebra 2 whenever you were dealing with quadratics. When you're going to factor, you want to make sure you're set equal to 0 because now I can set each of my factors equal to 0. Let's focus on sine squared of x minus 2 is equal to 0. I'm going to add the 2 onto the other side, and then I'm going to take the square root of both sides. Sine of x is equal to plus or minus the square root of 2. So there's something that's very important happening here. The radical 2 is actually bigger than 1. And if you recall from the graph of sine, which I just drew right here, the maximum value of sine is 1 and the lowest value is negative 1. If you were to type this into your calculator by getting x by himself and sine inverse of plus and minus radical 2, it would come up with an error. This is because this is a no solution. This can never happen because sine is bounded between 1 and negative 1. See, that's why it was very important for us not to divide away our tangent because he was actually going to produce our only solutions. So we're back to over here. Tangent of x is equal to 0. Okay? To isolate, we got to get x by itself, so we take the tan inverse of both sides. Tan inverse is equal to 0. And this is actually only going to happen in a couple spots. So we know it's going to happen at 0 degrees. We know tangent is undefined at 90 degrees. We know he is 0 at 180 degrees. And he's also 0 at 360 degrees. We have to convert all of these to radians, so we know 0 radians, pi, and 2 pi. These are our only 3 solutions because sine squared of x, that guy over here, produced no answers. All right, we're going to look at another trig equation, actually one where we don't get unit circle values, just so that you are aware that it does happen. So our equation is 3 times the quantity cosine of x minus 1 is equal to 3 minus 4 times cosine of x. So on the left-hand side, I'm actually going to distribute in my 3. And then I'm going to start to combine like terms. Why don't we add 4 cosine of x onto both sides. So now we have 7 cosine of x. And let's add the 3 onto both sides. So now we have is equal to 6. To isolate my variable and isolate my cosine, I'm going to divide both sides by 7. So cosine of x is equal to 6/7. This is when you're going to start to recognize, okay, this is definitely not one of my unit circle values. So to get x by itself, we'll take the cosine inverse of both sides. And depending upon what mode you are in, I'm going to put myself into degree mode and then I'll just convert. This is going to be actually 31 degrees. Okay, so he's over here, 31 degrees. This is a cosine. Cosine was equal to a positive 6/7. All students take calc. The other quadrant where cosine is positive is in the fourth quadrant, and they both should have a reference angle of 31 degrees. So if I'm at 360 and I go down by 31 degrees, that actually takes me to 329 degrees. Okay, so these are my 2 degree solutions. Now, of course, we still have to convert them into radians, and actually I'm going to let you take care of that because you should know that learning target as well. Alright, here is our last trigonometric equation. And this actually isn't that terrible of an equation, it just might sound a little bit tricky. Given sine of theta is equal to 4/5 in quadrant 1, find cosine of theta and tangent of theta. So I could have actually phrased this question a little bit differently. I could have said, given sine of theta is equal to 4/5 between the values of 0 and 90 degrees, or 0 and pi over 2, that you should also recognize means quadrant 1. Okay? We need to remember that the unit circle is actually just comprised of a bunch of right triangles. So if we're in the first quadrant, drawing my right triangle, here is theta. I remember my SOHCAHTOA from geometry. So sine of theta is equal to 4 over 5. Sine is also equal to opposite over hypotenuse. So theta is right here, and sine of theta, we have his opposite is 4, and his hypotenuse is 5. It actually gave me my ratio for me. To find cosine and tangent, I need the adjacent side. This is a right triangle, so I can now use my Pythagorean theorem. L squared plus 4 squared is equal to 5 squared, because leg squared plus leg squared is equal to hypotenuse squared. So let me just do a little bit of math here. Isolate my variable L by subtracting 16. Leg squared is equal to 9, so my leg is equal to 3. So my adjacent side here is 3. Therefore, cosine of theta, adjacent was 3, hypotenuse was 5. Tangent of theta, opposite from theta was 4, and adjacent was 5. And that is all the question was asking for. It was not actually asking me to solve for theta. It was asking me to find the exact values of cosine and tangent.